In this experiment, students should be able to extract the color of cocoa leaves using ethanol. And next, students should be also able to observe the UV visible absorption spectrums of cocoa leaves. And last but not least, students should be also able to establish the understandings of UV visible spectrometer, principles and also operations through the hands-on analysis of cocoa leaves extract. In this video, we will be discussing about the cocoa leaves, which is the vibrant emerald and treasure of our world. These leaves, celebrated for their biodiversity and also economic importance, holds within them a wealth of biochemical wonder crucial to their vitality and also endurance. We embark on this exploration armed with the tools of science, particularly the techniques of ethanol extractions combined with the UV spectrometer. Through this method, we can delve into the intricate web of compounds that define the essence of cocoa leaves, all without causing harms to this precious plant. Now, let's talk about the spectroscopy, a remarkable tool that allows us to measure the interactions of the molecules with the electromagnetic radiation. In the realms of the near ultraviolet ray and a visible light, with the energies ranging from 150 to 400 kilojoule per mole, lies a vast expanse of possibilities. Absorption spectroscopy, particularly when the molecules are dissolved in a transparent solvent, offers us a window into a concentrations of the various biomolecules with a linear precision. UV visible spectroscopy is an excellent technique for the following ligand binding reactions, enzyme catalysts, and also the conformational transitions in proteins and also nucleic acids. Spectroscopic measurements are very sensitive and non-destructive and require only small amounts of materials for analysis.
In order to extract the green dye from the cocoa leaves, we first gather cocoa leaves that has a rigid stem with a dark color green leaf, and then we store it inside a container to avoid contamination. Afterwards, we steam the cocoa leaves, and then we weight the cocoa leaves before put it into the oven for dehydration. The dehydration process took around 12 hours in 50 degrees Celsius. After the dehydration process is complete, we weight the cocoa leaves and then we recorded it and repeat the process of dehydration until we got a constant weight of the cocoa leaves. Afterwards, we pulverize the cocoa leaves inside a blender to make it into powdered form. In order to have a fine powder, we filter it using a mesh so we can avoid or remove all those big particles that didn't get grind properly. 20 grams of the powder will mix with 100 milliliters of ethanol inside a flask, and we filter it using a Whatman paper to remove any residue. The extraction was heated using a hot plate around 50 degrees Celsius while being stirred for 5 hours. During each hour, we filter those extractions to avoid residue building up. The extraction then was put inside a rotary evaporator and set it to 40 degrees Celsius and spin up to 100 RPM. The extraction then was safely stored inside a blue cap bottle for later use. 3.5 milliliter of cuvette was used to contain the extraction and ethanol separately. In order for us to get a spectrometer for the green dye, we first must get a base reading of the solvent that we use. That's why the 3.5 milliliter cuvette of ethanol was used to get the base reading, because we use ethanol as the solvent for our extraction. After we get the base reading, we can use spectroscopy to get the absorbance value for our green extraction dye.
Hi, my name is Adli Haziq, A2897, and today I'm going to chat about how does UV visible spectrometer work. So, first of all, UV visible spectrometry, also known as UV visible spectroscopy, is a technique used to measure the absorption of ultraviolet and visible light by molecules. It's widely used method in chemistry, biochemistry, and physics. Okay, right now I'm going to tell about components of UV visible spectroscopy. So first, we have sample container. When compared to the radiation flowing through, the sample container and reference solution should be transparent. In the visible and ultraviolet spectrums, few silica or quartz cuvettes are frequently employed for spectroscopy. Okay, for the second component, if we have a detector, the photo multiplier tube, which has an anode, dynose, and photoemissive cathode, is the most widely used detector in UV visible spectroscopy. When radiation photons touch a photoemissive cathode, it releases electrons. In contrast, the dynose releases several electrons each time an electron strikes them. Radiation photons contact the cathode as it enters the tube, causing it to release several electrons. The initial dynode will emit more electrons with each incident electron that strikes it as the released electron accelerate and impact it. And that is a simple way how to I explain the detector. Okay, next component is light source. Light source that we use in the spectrophotometer is a form of polychromatic. Polychromatic light contains a wide range of spectrum, but the scientific equipment will only be using UV spectrum. A spectrometer uses two different kinds of light sources: tungsten, carbon, mercury vapor. Deuterium and hydrogen lamps are used to these sources, whereas tungsten, mercury vapor, and xenon lamps are used for UV sources. And the last component of UV visible spectrometer is wavelength selection. In order to enable sample evaluation form, the wavelength the light source generates wavelength selection is done to ascertain which wavelength is appropriate for the type of analyte and sample. The monochromator will receive polychromatic radiation with several wavelengths through the entrance seat. Using a prism or grating, the beam will collimate, strike the dispersing element at a particular angle and split into many component wavelengths. Through the exit slit, a single wavelength of radiation will exit the monochromator. To improve the signal to noise ratio and enable more accurate measurement, certain UV visible spectrometers limit the wavelength of light using filters and monochromators. I think that's all for me. Thank you very much.
After high-intense researches that we have done with our group, these are the results that we gained from our experience. So, as you see from the graph, it shows that cocoa leaf dye absorbs light from minimum 200 nanometers to maximum 500 nanometers. And the major absorption of light is between 200 and 350 nanometers, which indicates us that the cocoa leaf dye absorbs light in mostly ultraviolet UV region. And as you see from the graph, the absorption decreases from 350 to 500, which indicates us that the cocoa leaf dye absorbs less light in a visible region than ultraviolet region. Let's go.